All right, I guess I can start going through pull requests. Let's see, there's one in flight from Mohammed, I think. That's Mogab, is that you? Yep. That switches to monotonic clocks. All good, but we want to avoid the coarse ones, I think, for anything that's measuring short latencies. But that's under discussion, undergoing review. A couple merged. Radic had one that changed the encrypt decrypt calls to have variants that don't use bufferless but use just pointers. Those sped up the signature calculations notably. Let's see, Peter had one that made the log subsystem buffer the writes instead of doing a separate syscall for every single log entry. That helps a lot when the log is, or when you're logging a lot of stuff. Both those merged. Mark's priority caching thing, I think, is it ready for to go through QA, Mark?
Yeah, I think so. I mean, hopefully that will catch anything odd, given that we can get through these other ones.
All right. Yeah, I think it's tagged. I just haven't run another batch through that isn't mimic related, so might wait till next week. Along the same category as the new bitmap allocator from Igor, that needs to go through QA too, but looks pretty promising. It swaps out the old implementation for the new implementation, and the pull request also just switches the default to the new one, since in his testing it was better on every dimension basically than the stupid allocator. So since we're in the beginning of the null cycle, I think we might as well just flip it and then had to wait it for 9 months. That's it. Let's see, there's an RBD one that I don't know anything about. There's Adam's one that fixes the hashing thing. The good news there is that just adding in the non-string fields into the hash seemed to fix the problem that the user was seeing. So I think it's just a matter of respinning that pull request so that it's updating the normal default hash method for each object and GH object instead of having to special case each container. I haven't seen this one, BlueFS reducing bufferless rebuilds. Dun, dun, dun. Okay, yep, that sounds good. Hasn't been reviewed yet. Maybe request a review for that. Let's see, so there's some other crypto stuff. I don't know what this key handler, oh, this is the old one, right? Is Redick here?
I am. Which one?
Yeah, this is the old one, 21179, crypto AES key handler cleanups from Kifu. Because we already merged the thing that changed to OpenSSL. Is this the one that ended up not working out, or is this something?
I think it's something different. I've took one or two commits from Kifu that was originally in his branch, but have been removed after testing.
Got it. Okay. So that Kifu, I'll just ping Kifu and see. Since that other pull request did merge, so either update that or close it. Let's see. There's a periodic discard thing that still has some problems, needs some updating. The EC local read thing caused failures in QA. I don't know if it has been updated since then. Probably not. I don't know how big of a deal this is, so. Yeah, I might. There are other scrub issues with this around the same time, so I think I'll try rebasing this. This removing memory induction laters and strided op work queue. Let's see, 1997.
It's I guess it's the old one waiting for that was waiting for the rework of sharded work queue. I guess I can resurrect Yep, it's merged. I guess I can resurrect that and take a look whether there is a difference after the rework.
Okay. Sounds good. There's the power of two stuff. Peter reviewed that. The big question is whether these power of two things, this level of automation actually is noticeable. I confess I'm a little bit skeptical that these are going to have a noticeable impact also. But
I guess it depends actually on a variant of division that is being replaced. If you are going to replace the division by 8 bits integer or even a 32 bits integer, the cost of this division is pretty low, around 9 cycles. However, when you are doing division by 64 bits, which isn't unusual in Ceph, you can expect, based on instruction tables, you can expect latency around between 30 to even 90 cycles. It can be painful, but depends, as usual.
Okay. I think that the Mutic stuff is probably more promising. I would probably go there first, but
I guess the main.
Go ahead.
I guess the main benefit from the P2 wrapper is a cleanup. We have many places when we are doing bit twiddling that could be replaced by P2T, offering much better abstraction and possibility to integrate with our configuration management subsystem.
Yeah.
I mean, something like having automatic validation, whether it's P2 or not, for shards, sizes, etc.
Yeah, it seems more compelling to me as a enforcement of that value as a power of two, and the optimization is sort of secondary, I guess. But certainly having that as part of the config, so we can specify that these config options have to be powers of two, that would be helpful.
Yep, exactly, and we don't need to assert multiple times if we are taking P2T. It's being validated once.
Yep.
Why we shouldn't then just go for assuming that everywhere we need a power of two, we just assume power of two. So, for example, instead of asking user to enter power of two directly, we just ask him to enter particular
number of bits.
Number. So he can calculate it on its own. For example, if we need something like 1 kilobyte, he can type just 10, so it's 2 to power of 10, so and so on. And then we
can store it that way, I think, but I think it's important to make the user-facing part easy to understand. So having them enter a number of bits to shift instead of like 4K is probably not a good thing.
Yeah, I agree, but
at the config end, right? There's like only one for that happens. Yeah. I mean, isn't that what how the P2 type is implemented? Is it just storing the bit shift, or is it actually the integer value?
If I record correctly, it stores actual value because of easier conversion, no conversion costs, but extracting the exponent is being made with bit counting instructions, so it's pretty fast. Yeah. But of course, it's a single class. We can shift, no problem.
Yep, that makes sense to me. Go either way. Okay. What else is there? Yeah, all this other stuff is getting kind of old. I'm not sure if any of this is still relevant right now. Okay, so a couple items here. See, there's the SSD write buffer idea that Adam started working on. Do you want to give a brief overview of that, Adam? You're muted.
Sorry, I was muted. Yeah. Radek helped already. Well, the idea is quite simple. It's about to utilize observation that I can actually make flush to SSD, to some fast SSD, instead of waiting for flush to spin disks. And actually all the infrastructures, I will just share, maybe pull requests, and there is also a link to data inside. And the data is written on a write path to two places. It's written to HDD, and then also written to some fast device. I mean NVMe or SSD. And we at the waiting, when flush is done, waiting is done only for commit the data on SSD. So actually, until for as long as the buffering is done on SSD, there is no waiting for flush on a hard disk. Only when there is a need to make a space for a next batch of write operations, there is also, of course, waiting that all the data from the cache has to be moved to hard disks. I mean, the pull request is not obviously is not complete, but it's enough to measure the performance, potential performance improvement that can be achieved. And here is the graph for performance boost. It looks like in the best case it gets like plus 30% IOPS. Okay, but just I will just in a second share with everyone. There is no problem to share with. Can view, but everyone, not more.
Google
Okay.
Docs in Red Hat doesn't really share publicly with the link, unfortunately. So you might just share your screen.
I cannot make it more share with more people. I can only
individuals.
Only with at Red Hat.
Yeah.
Okay.
But if you,
I was confused.
Screen,
Okay, that can also done. Actually, I cannot share right now. I'm sorry. I need an extension. That's I will do that later. I mean, and the only thing that is and the boost performance is, I mean, expected in the range of plus 30%. But what is a mystery for me is why, when there is like 90 and 100% of writes, because when there is 0% of writes, there is, of course, the having turned on or off the cache doesn't really affect anything. But I don't know why having 100% writes makes it work less efficiently. and I intend to test it because my intuition is that I have overtaxed the SSD drive that I used for cache, but that needs to be tested. And I guess that's it for the entire solution. It doesn't require to work efficiently large space for a cache. In my testing, it was 60, 2 rows of and 60 megabytes was used as a cache. Just that.
Okay. So I mean, this is kind of bringing back something that we had with file store where all data went to the SSD and then the writes to the hard disk could be less lazily or more lazily ordered, fewer syncs on the hard disk. I think the trade-off is that it means more burnout or whatever on your SSD. Like your SSD won't last as long because you're sending all writes there. So
there are solutions like flash cache, bcache, and I'm aware of Intel working on iCache, caching acceleration software. So what's the advantage of this over, for example, flash cache?
Simplicity of deployment, maybe. Although I guess we can make Ceph volume set up a DM cache thing also.
I mean, there's only also one difference, that the moment that the data is synchronized is well defined in this solution. You just control when you sync the data to HDD.
Yeah. I mean, so flash cache has this write back mode. Do we know if bcache or DM cache have this mode also? Or they're just buffering writes on the SSD? Anybody know? I guess that's a question to answer. I guess one nice thing, if BlueStore is going to do it, then it could carve out a region of the SSD to do it, without having to like have a separate partition or whatever, and configure the DM cache layer underneath. I think there's this larger question of like how well is bcache or DM cache or whatever going to help in the BlueStore case, given that BlueStore is already putting all of its metadata on the SSD. And that I think is kind of an open question.
I think generally speaking, the kind of the low-hanging fruit would be just to even randomly place data on the SSD for whatever space is available and not try to do anything too complicated with promotions or demotions. Just kind of have some portion of it there and gain whatever benefit we can by that without trying to be too smart.
Yeah. With DM cache or bcache, you mean?
Well, in general, no matter what we do,
okay.
it shouldn't. It seems to me like every time we go down that path of trying to do something too clever with moving things around quickly, maybe slowly, right? Maybe if it's really slow, look at really coarse statistics, and then maybe make some promotion or demotion decisions, but don't try to Yeah.
Yeah, I mean, this would be a great area for somebody to like sit down and like do kind of some comprehensive testing, because the best results we've had with iCache and with DM cache with file store, or when it managed to just get all of the XFS metadata on the SSD and then and nothing else without doing any like other fancy tiering. That seemed to have the best impact.
Yep.
And BlueStore already does that. Just out of the box, it puts all of our XDB on the SSD. So it'd be interesting to see the file store baseline, file store with DM cache, BlueStore baseline, I guess, is already with the cache. I guess we can't really compare the difference there. But yeah, I don't know. Josh, there were two talks at least at CephaloCon about doing Bcache and doing, can't remember what the other one was. I think one of them was an OVH talk too, right? Wasn't that? I think one of the Bcache ones was OVH.
Oh, Flash cache.
Flash cache. And was that with BlueStore?
No, FileStore.
It was FileStore. Okay. Have you guys tried using Flash cache with BlueStore?
Not yet.
Not yet. Okay. All right. Well, I guess that's the next big question here.
Yeah, I think the other one was about a module called DM Write Boost, which was doing the kind of write coalescing and write back from the SSD directly, but it's not. I think it's not a mainline module at this point.
Okay, it's like doing just write buffering and not anything else.
I think so. I forgot the details. It was in Chinese, so I didn't get the entire context.
Log structured caching for Linux.
One thing that I will note is that we're already in BlueStore kind of pushing. We're not getting significantly more improvement without some code modifications by running BlueStore on faster devices. The devices are fast enough already that we're not getting a whole lot of gain by going on even faster hardware. I think we have probably other things that we need to worry about first, at least with super devices, right?
That's definitely true when we're running on straight flash, but this is about accelerating hard disks with some flash.
Yeah, that's absolutely. Yeah, I guess I was thinking, I had kind of moved on to thinking about like SSDs with like NVDIMM
or something. I wouldn't go there.
Yeah,
I think you're right.
It won't help.
Yeah. Okay. Well, it sounds to me like the big to-do item is still just to go try some of these other caching layers and see if they help.
Well, I will try to use Inserta to make such test. I don't know if that will be okay, but I will try, and to maybe next performance be able to have some numbers.
Okay, that would be awesome. Okay. What else? OST memory usage. Mark did a whole bunch of work this week to try to figure out where the OST memory is going. Do you want to just give the highlights? I guess you can't share the graphs or whatever that you have so far, but
no, there's one. There was a graph I uploaded yesterday to Google Drive, but I can't share it easily. It was on IRC though, if anyone has the backtrace there. But anyway, the gist of it is that there's no like silver bullet here in terms of, we've got a big memory leak or one thing is really bad. When you kind of take all of the different things that use memory in Ceph: the PG log, the BlueStore metacache, the BlueStore data cache, the KV cache, the block cache rather. All of this stuff adds up, and it adds up faster than you might believe just looking at the mempool stats. For the BlueStore cache, for example, the meta and data cache, in the configuration I was testing, those combined were set to use about 1.8 gigabytes of memory. And correctly, that was what was allocated in the mempool, and the stats showed that that's what was being consumed. But the RSS memory usage of the process actually increased by around 3.2 or 3.3 gigabytes instead of 1.8. That kind of amplification also appears to happen, maybe to a lesser extent, with pglog. And also in RocksDB with the block cache, it appears that it may be that it's actually increasing memory usage by a greater amount than has been allocated to it as well. It's probably, Sage, I think you're probably right that this is heap fragmentation. I am not sure if there could be other things going on as well. I looked at the heap stats from TC Malik, and it wasn't like there was a whole ton of RSS memory to be freed. I think yesterday when we looked, it was about like close to 7 gigs full OSD memory usage, and maybe 600 of it could be freed back to the OS. So I mean, there's some, but maybe not a ton. The free list, the various free lists in TC Malik were pretty small. They did not consume a ton of memory, and the cache there. So overall, it looks like we are consuming most of that memory, and we are seeing an amplification effect for all of these things. So probably the next step is to figure out under what circumstances we see what kind of amplifications for what kind of data, and then I guess try to kind of create factors for all of these. Unfortunately, though, it's pretty easy to get up to like 3 gigs of RSS memory without even having the BlueStore caches doing much of anything at all. We can shrink other stuff down and kind of massage things to give BlueStore some cache. But this is where I think having some kind of mechanism for trying to shift memory around based on where it's needed is probably going to be really important, especially if we're trying to restrict the caches beyond kind of what we do currently. So that's what I've got right now. I'll have lots more data next week, and hopefully more analysis with useful results. But that's kind of where I see things now.
Okay. Sounds good.
Sage, do you think is it worth trying to kind of look at the whole picture of like heap fragmentation and like changing things so that we can try to improve that?
I mean, if there are ways that we can reduce the fragmentation, that would be great. I'm not sure what those are.
The nasty, scary one, right, would probably be to like allocate big chunks of memory for like BlueStore, right?
Yeah, I mean, yeah, yeah. I don't know if there's a way to like have different arenas or whatever you call them for like different things. So if like the BlueStore cache used a totally independent set of a totally independent heap than everything else, then they wouldn't interfere. Not really sure.
Okay.
I don't know. I mean, the thing that worries me is that it seems to change so wildly between an RGW and an RBD workload. And I'm not sure that that's because we're actually caching different data. I'm afraid that it's because we're also using the heap for other unrelated things, and it has sort of a interfering effect on how things get laid out.
Yeah.
But maybe that's not true. Maybe we are just caching more or different stuff. Maybe there are more. I guess there are more X adders on RGW objects than there are RBD objects. Maybe that's what the difference is. I don't really know. But even if that were the case, then if we could like put all of those X adders in like a different pool of the heap, so that they could like be all fragmented and inefficient, but then everything else would still be laid out more nicely. Or maybe that really just means that we have like independent slabs for like all of these different types. So like every type that we has a known size that is common has an independent instead of coming out of the same memory. There are all those boost memory pool things or whatever, but they're not like, they're meant for cases that are thread safe or whatever. They're not. Whereas, TC malloc, the general purpose allocator, has all the like per thread and per CPU, pools or whatever. Does anybody know more about memory allocators? It seems like there should be a way to like have like a whole bunch of different, like, I don't know if arena is the right word or not, but like different pools or whatever that all the different for known types.
My observation with memory allocators from embedded world is like that if we have some unusual expansion of memory, I mean RSS versus what we observe to have, it's usually because of realloc. We tend to have some alloc, like let's say 4 kilobytes for some reason, and then we trim it by realloc to some smaller part, and this causes a fragmentation there, because in next iteration of allocator tries, because you ask for 4 kilobytes, so it gives you from some pool of large chunks, and that way you can have that kind of behavior. But it will not be consistent with what Mark is telling, because this way you will have always growing the size of RSS. It will not stop. So that's the only thing I can add to this.
Sage, one thing I've been a little bit worried about is how much the use of the intrusive boost containers may be kind of fragmenting things versus things like vector.
I mean, in general, the intrusive containers are more memory efficient because you don't have all the little list nodes or standard map nodes. So in comparison to standard list and standard map, or even unordered map, then they're better. But obviously none of them are better than a vector.
Yeah. I'm wondering if the overhead of the benefits that you get from using like a boost intrusive list or whatever, if maybe they appear better on the surface, but once you actually like start dealing with all of the fragmentation everywhere, if maybe you're better off just dealing with the overhead of dealing with the vector, but having the contiguous memory layout.
Yeah. I think probably the parallel that we're looking for is not so much vector, but flat map, which is just puts it all in contiguous memory. I don't know. I mean, it really seems like we're going to have the least fragmentation if we divide things up by the size of the thing being allocated. The kernel does it by powers of 2. If if you're using like explicit pools, then it can be any size, and you have one like per type for every or every unique size of object that you're allocating. Then you can lay them out contiguously. I'm not really sure what. I guess I'm not sure what the options are for doing something like that with the user space allocator are, though. Or maybe this is something that the allocator tcmalloc itself is already doing.
Yes, it is.
Does it like lay them out in totally independent memory regions? So
it has
small
just
allocations.
Similarly to what is kernel is doing, it uses the different pools within the arena for small allocations and other totally different mechanism for large allocations. So all the small allocations will always be actually will not eat up more space than the like 5-10% because of some alignment for these buckets of allocations.
Okay.
I mean, when you start and you allocate actually the small chunk. I mean, the realloc thing does not fit into that schema.
Mark, when you were looking at the tcmalloc heap stats, does that tell you like how much is actually allocated versus how much is consumed?
Yes. Let me see if I have the stats here. I'm pretty sure I copied them in somewhere.
I'm just wondering if this is a case of tcmalloc sort of knowing that it's, or acknowledging that it's not effectively using memory efficiently, or if there are just a whole bunch of allocations that we're not paying attention to that aren't being tracked by mempools. Because we have like a 2x delta between those, right? Between the mempool. Wish I could find that document that you shared. It had a pretty good graph, but
yeah. Oh, my network is back here. Let me see if I can get this pasted, and then
like address. Here it is. I have it actually. Bonk. Yeah, I mean this shows like mempool pretty nice and flat around like 2.3 to 2.5, 2.6 gigs, and then but RSS sort of like starts at 5 and goes up to almost 7.
Sage, if folks can hang on a little bit here, I've got some more data that I can upload to that same location.
Yeah, I can share my screen, but you're going to get both of them.
Versions.
I just can see that very well, but yeah, this is the total for mempools.
Try downloading the newest version of that file now if you have the link still.
Yeah, I think it looks the same, I think. I'm not sure.
But there should be a couple of new tabs.
Yeah, no. I think the link I have cached is just the wrong one.
Okay,
oh, wait,
let me see.
Maybe not. Maybe not. Let me try it again. Yeah, I can't do it. Well, yeah, okay. It seems like the next step is to look at the tcmalloc dumps and see if it if it thinks that it is only allocating what the mempools think they're allocating, or if there really is like significantly more than that allocated from the user perspective. And if so, then the path is to go figure out where we're using the heap that isn't being tracked by mempools. If not, then the question is, why is tcmalloc using, is it fragmented to the factor of 100% or 2x usage or whatever? And then I think the question is, like, who can we talk to that works on memory allocators and understands how they work better and can make a recommendation or ways to use them more effectively or something. Does that make sense?
So, yes, definitely. Did you see the link in IRC I pasted there? That might get you the new version, possibly.
Yeah, let me try it.
And then also,
oh, yep, that's the new version. A little bit.
so the two other ones that are there are basically, the second one is still assigning the KV cache the same amount of memory overall by adjusting the total cache size and the ratios, but then eliminating, more or less eliminating the BlueStorm meta and data caches.
Okay.
Does that make sense?
Yeah, but there again, the mempool total is like under a gig, and the actual RSS is like up to 3 gigs.
Yep.
Thing is
exactly. Now, a big portion of that is the KV cache. There's like 1.2 gigabytes devoted to KV.
okay.
So it's not. Yep. If you look at the next one, the third one, then that is basically the same thing, but now with the number of PGs reduced from 256 down to 8.
Okay, so that goes up to 3.5. They both seem to have about the same total. They're a little.
No. The third one is a little over
2.5. Oh, so that saves a gig. Okay.
Yep. So that drops us about another gig. And now, actually, I'm in the middle of running a test where we more or less eliminate the KV cache. It's set to 32 megs. So we drop it from 1.2 gigs down to 32 megs. And that test is running super slow because now, everything is hitting the disk for reads during writes.
Mm-hmm.
But at the moment, I'm about halfway through the test. And according to Top, anyway, the RSS memory usage of the OSD process is about 840 megs. So we're under a gig.
Mm-hmm.
And that is still with the Red Hat log buffers being set to 256 megabytes, 4 of them. So it could be up to 1 gig, probably typically more around 256 megs. So we could reduce it further by, reducing that.
Okay. Yeah, I mean, it looks to me here like we've accounted for most of the per PG, the stuff that's proportional to the PG count, because between those second and third tabs, we go from like 800 megs from mempools to basically 0 or close to it, and the total drops down about a gig. So like the overhead there is like maybe 20%, 30%. Which isn't so bad. But where is this other 2 gigs going? I think that's the part that, I mean, is that the RocksDB write buffer? Is it, there's the RocksDB cache itself, but that's.
Well, like I said, the block cache is currently set at 1.2, so.
Okay, so that's half of it, I guess. And then maybe the other half is 2 write buffers.
Yeah, it could be 2 write buffers. So that will be the next test I'll run, is reducing those way down. I mean, right now, we're, like I said, with the write buffers and without having much in KV cache, it's sitting at like 840 megs. So.
Oh, I see. Okay, so it can't be that. can't be just the right buffers because that would be a cake.
Well,
yeah. Okay.
But that would probably the right buffers. I imagine that we're filling one and then we're flushing or we're compacting that once we filled it and the next one starts writing up. So my guess is that if we don't fill the next one before the compaction finishes, we're probably sitting between 256 megs and 512 megs typically for memory consumed by the right buffers. Unless we're backing up farther than that, which we could be, but I don't think any of this is unreasonable if you assume that there's an amplification effect for just about everything.
Yeah. Okay. Okay. This is the RPD workload.
This is an RGW workload, a 16K object RGW workload.
Okay.
One last comment though, Sage, do you see the light blue OSD PG log line on the first graph? How it kind of like periodically increases?
Mm-hmm.
That was what I was talking about in stand-up, that I don't have any good explanation for why after several hours, periodically here we see this increase.
Yeah, and this is the mempool accounting for it, which is sort of odd.
And it seems to, it's mirrored here right in the RSS memory usage, which makes sense because it's going up. But then if you look at the third graph, we still see this increase, these bumps in the RSS memory usage, but we've only got 8 PGs. I mean, it doesn't make any sense to me why, with such a smaller PG count, we'd still see that big of an increase in RSS memory usage like we did in the other ones.
So it's around 5,000 seconds or 4,500 seconds. How long is that? An hour.
Yeah, essentially. A little over an hour in. And then another, hour and a half or something. I don't know.
Huh. I don't know. Another mystery.
Yeah.
Something to think about. All right. Okay. Well, let's see if we can narrow down the right buffer stuff, I guess, on the RocksDB side, and then sounds good. I put the Ceph mutex stuff here on the list. I don't know if there's a lot to discuss there or not. We talked about this a lot several months ago about making a mutex class that compiles away without all the locked up stuff. But I think Radek made a change to the op tracker that did a bunch of stuff. One of the things was changing the mutex out, and that overall it made a big impact. So I'm optimistic that just compiling locked up away is going to help everywhere.
Could be. We have actually the change is related to create request of tracker. The branch deals with multiple things. One of those is using our abstraction over mutexes, and it seems it's costly. Not even because, not only because the lock unlock things, but also because of the construction costs. They are much bigger in comparison to plain mutex, and it's painful in case of tracked op, because each time for each single operation we are constructing a new instance.
Okay.
However, a lot of other things are in the pull request. In the branch. It's at the moment it's work in progress. Like switching to a small vector for the events array that each tracked op has. Also removing a lot of mutex dance, because we are initially, before the patches, we were constructing tracktop, registering it inside of tracker, and just after that, filling some events inside. This means that because it's at the moment it was registered, we had to take and we had to operate under mutex, and we were doing that. We are unlocking the same mutex many times, around 5. I just removed that, and also I've killed the sequential, the seq field of tracktop to eradicate some cache ping pong we had between messenger threads. In very initial testing on Incerta, but on a cluster deployed not with CBT but vstart instead, I'm seeing up to 10% of change. But still, it's not our official methodology. Please take that with a lot of, with more than grain of salt. It's not the official testing. Official testing is always made at Incerta using CBT.
Yep. Okay.
And also, even more importantly, it's a scenario with 100 cache hits, which exposes latency, which exposes overhead of especially of messengers, of the front end of the OSD pipeline.
Yep. Yeah. So best case. Okay. Well, okay. So that's all great. Coming on the mutex thing specifically, I'm just wondering if the path forward that's going to like lead to the fewest merge conflicts or whatever is to do it in baby steps.
Yeah.
So maybe it's make our mutex implementation whatever the C++ compliant or whatever, where you can use the unique locker and lock guard. So implement the lowercase lock and unlock, and then introduce a compile option that compiles out all the locked up stuff to the current class, and then maybe rename it to be a lowercase thing just to be less annoying about everything. Is that all? Does that make sense?
Sounds good. I guess we definitely don't want to make a one huge, extremely huge pull request dealing with each single mutex occurrence in the code base. It would be a nightmare to maintain such PI.
Right. Yeah, you want to have like the enabling bits, so lowercase aliases for the methods, and then for the search and replace stuff, go like directory by directory or whatever. So because it'll go through different QA suites, and we want to minimize the blast radius of the conflicts or whatever.
Also, I can just remove some patches from the branch and estimate the impact of the mutex transition itself.
Yeah. Okay. Yeah. One sort of open question in my mind is that if we make the I guess the majority of the mutexes are passing constant strings into the constructor for the names, and so if we compile away all the locked up stuff, there'll be no overhead for that. Like that'll all just also compile away mostly. But there are a few cases where we're actually in the caller, we construct unique strings to name the mutexes, and that won't compile away.
Maybe there is a way.
But
under some constraints, language allows, under some severe constraints, the language allows us to take address of C string as a template parameter. But of course, it has to be associated with appropriate storage.
I guess it's not really. I mean, the worst case, we can just put an if-def in the callers too, so they don't bother constructing strings if we're compiling it anyway. But I guess I wouldn't worry about that for now. We can get most of the benefit of compiling anyway without worrying about it. Okay.
There was a thing related to buffer circulation in the huge pages for
right.
file writer of BlueFS.
Right.
I would like to extend the PR with the buffer recirculation. I'm a bit nervous that at the moment we would go to kernel each time for each map, immune map. It can be painful.
The thing is that we're only doing it per huge page, which is like, how big are they? They're gigabyte?
It depends.
Megabyte?
It depends. 2 megs.
2 megs. So that's like, this is the wall buffer in BlueFS, which is not big. So we're probably, at most, we're going to call this a couple times a second. So I'm not sure it's worth optimizing for that case. At least in the BlueFS case.
So I saw during profiling, I saw there was around 2% of cycles of the KV sync thread spent in memmap related stuff.
Okay. Okay.
And what makes me nervous is only the direct cost of the syscall. However, when you are dealing with kernel, there are a lot of indirect costs like cache pollutions, etc.
Yeah. So I guess the thing I would worry about is that if you make anything that's per thread, then we have suddenly all these assumptions that you're going to reuse pages on the same threads. And I'm not sure that that's actually the case. And it would be very easy to like always be allocating them over here and freeing them over here, or end up with like just a bunch of unused huge pages across a bunch of threads that aren't getting freed. So if you want to try avoiding mmap, maybe the first thing to do is just try a centralized reuse queue protected by a spin lock, which is clearly not the fastest thing ever, but it's probably faster than a kernel syscall.
It should be, but it could be also dangerous, as kernel has absolutely no knowledge that you are synchronizing. So in case of the preemption of spin lock owner, wow, it could be a lot of pain.
Yeah. I thought the spin lock implementation like hinted or something. Maybe not.
Not ours.
Anyway, I would suggest just trying that, and see, or maybe there's a lockless queue or something. Just a FIFO,
but
right?
maybe we could go another way. Have something like small, extremely small, maybe one huge page per cache thread, then some guy responsible for basically a registry with freeing mechanism that will be called quite rarely, maybe one time per second or something like that.
And that just goes and cleans them up.
Yep.
Yeah, I worry about over-engineering something super complicated.
Sure, it might be.
Try the simple thing first and see if it's okay.
Yeah, definitely.
Okay. Anything else? All right, cool. Thanks, everyone.
See you later, guys.
Yeah.
Thank you.